Hi guys, welcome back to my channel. Today we'll discuss about closure property of context-free language. Introduction to context-free language. Context-free language are class of formal language generated by context-free grammar. They are widely used in programming language syntax and understanding their closure property is essential for analyzing their behavior under the various operations. Definition of closure property. Closure property refer to the ability of the class of language to remain within a class after a specific operation. For closure free language, we examine how to behave under union, instruction, and concatenation. These properties have helped in determining their limits and capability for context free grammar. Closure under the union. The class of context free language is closure under the union. This means that if L1 and L2 CF, then L1, L2 are also CFL. This closure property can be demonstrated by the constructing a new grammar and generates both language. Example of closure, union closure. A context-free grammar can be constructed to the represented this union. Closure under the concatenation. Context-free language are also used under concatenation. L1 and N2. Then the language L1 and 2 formally concatenation string from the L1 and 2 CFL. This property can be proven by constructing a grammar that combines a grammar L1 and L2. Example of concatenation closure. The concatenation L1 and L2. The grammar can be created generate string in this form. Closure under the leen star. Context-free language are closed under the kin star operation. The set of string formed by the concatenation 0 or more string from L is also CFL. Example of clean star closure property. The clean star L. We include string by AB, AAB, etc. Closure number instruction with regular language. Context-free language are closed under the instruction with regular language. L1 is CFL is L2 regular language, then L1 L2 CFL. Closure property is useful when dealing with constraint defined in regular language. Example of instruction of regular language. This instruction L1 and L2. Result can be generated using context-free language. Non-closure under instruction. Context-free language are not closed under instruction with other CFL. This means instruction of two CFL may not result CFL. Understanding this limitation is crucial for the language analysis. Example of non-closure instruction. This illustrates non-closure property. Non-closure under complement. Context-free language are not closed under complement. Complement of CFL may not be CFL. This significant may considering the property of language recognized. Example for non-closure under complement. The complement of L include string like AA, BB, etc., which is not CFL. This example highlights a complexity of language property closure under the reverse. Context-free language are closed under the reversal operation. L is CFL, then reverse language LR is also CFL. This property is used when considering language that can be breakdown. Example. Implementation of closure property. The closure property of context-free language impacts the language design and techniques. This informs development of compare and the imperatives and programming language. Understanding this property aids in providing language equivalence and disability. Summary of closure property. Context-free language are closed under union, concatenation, clean star, and insertion with regular language. They are not closed under the instruction with the CFL complement. The complement property help define in limits and capability CFL computation application in computer science, and they assist in language recognizing and matching algorithm. They all have implementation in atom theory, a formal language processing. Conclusion and further reading. Understanding closure property of context-free language is a vital for theoretical computer science. Further reading can be includes topics like and patching techniques. Exporting this concept enhance comprehensive a formal language that their application. Thank you.